All right, in this video, I'm going to go over an exponential growth and decay application. So application meaning just a word problem using the exponential growth and decay that we've talked about in previous videos. So the population in thousands of Austin, Texas during a recent decade can be approximated by y equals 494.29 times 1.03 to the t, where t is the number of years since the beginning of the decade. So we need to tell whether the model represents exponential growth or an exponential decay. So the first thing I notice is this is an equation with t there. You can look at the two different types of equations from the beginning, in my previous video, and I notice this represents y equals a, and we're doing 1 plus or minus, we're not sure which yet, r to the t, because we're talking about time, and this equation had to deal with time too. So you can kind of match up the pieces where A is 494.29 and that's 1 plus or minus R also is this 1.03 piece. So we need to tell whether the model represents exponential growth or exponential decay. There's two ways of going about doing this. One way you can do it is you can just take this, use your graphing calculator and plug it in, but you put an X there, graph it and just look at what the graph looks like. If it's a graph that when you go left to right goes up, that's growth. When it comes down from left to right, that's decay. So that's one way you can easily tell. Another way we can tell is, I know the inside of this parentheses needs to match up with this 1 plus or minus r. So we got to think, if we're taking 1 and we're adding or subtracting r, adding being growth or subtracting being decay, we think, how did we go from 1 to 1.03? Did we add or subtract to 1 to go to 1.03? And looking at that, you can immediately tell, well, we had to add some number to get from 1 to 1.03. So that's another way you would know how this is growth. So you can graph it and you would see it's going up. That's growth. Since it's 1.03, that's also growth. One final way you can also tell this is also very similar to the other exponential equation, y equals a times b to the x. And in the previous video, remember how I talked about that b, that's your growth or decay factor. If that's greater than 1, it's growth. If it's between 0 and 1, it's decay. So 1.03 being bigger than 1, that confirms that this is growth. So since it's growth, I know I'm dealing with the 1 equals a1 plus r to the t. That's how I know for sure this is growth. So our next question says, identify the annual percent increase or decrease of the population. So they want to know the percentage that we're growing, increasing, or decaying, decreasing. Well, I already know it's increasing. I know it's growth, so we know it's dealing with increase. We just have to figure out what r is. How we're going to do this is it's pretty interesting. You just look for patterns here. So this equation matches up with this one. I know the 494.29 matches up with A. I know the inside of the parentheses matches up with here, and I know T is T. What they're asking for when they're asking for the percent, they're looking for R there. They want to know what R is. So we got to figure out this inside piece. So this 1 plus r is the same as 1.03. So what you could do is you could take this, set it equal to 1.03. So 1 plus r is equal to 1.03. So I know the inside here is the same as the inside here. So what I did is I just set them equal to each other since I know they're supposed to be the same. And since I want to know, hey, what's the percent increase or decrease, I just have to solve this for r. So it's a very, very basic equation there. So you just subtract 1 from both sides. And on the left side, we get r. On the right side, 1.03 minus 1 is 0.03. But they want to know the percent. 0.03 is 3%. Part C here, I said estimate the population 3 years after the beginning of the decade. So what I'm given here is a time. So looking at the equation, I have all that information, where t is the number of years since the beginning of the decade. Well, they want to know what's the population 3 years after the beginning of that decade. So they're telling us t is 3. So all we have to do is we need to take this value and let's just plug it into this equation. So that's going to look like y equals 494.29 parentheses 1.03 parentheses into an exponent 3. And what we're going to do with that is we're going to take it, we're going to use a calculator, and we're going to solve that. So taking that, you want to plug it in just like you see it. So where I have parentheses, you should have parentheses. So we have 494.29, 1.03 to the third. And when you plug that into a calculator, you're going to end up with 540.12. Now, remember when they talked about it, they said the population is in thousands, so that's 540.12 in thousands. So be paying attention to what units are what. And that is an application of exponential growth and decay.